In May of 2017, Purdue University launched GLASS, Global to Local Analysis of System Sustainability. This is a project designed to tackle the challenge of linking local sustainability stresses and solutions to global drivers and consequences. The project is built on the idea that fine-scale analysis of the Sustainable Development Goals within a global framework is required to promote responsible public and private investment, sustainable management, and collective action. Current approaches are limited. There's a great deal of important work going on underway in this area, but there are three areas where we think they're particularly limited. The first is the disciplinary orientation. The Sustainable Development Goals are fundamentally interdisciplinary in nature. Approaches that largely are driven by economists like myself, hydrologists, climate scientists, for example, will ultimately prove too narrow in their analyses. So interdisciplinarity is fundamental. A second limitation has to do with the geographic focus. By their very nature, land and water sustainability challenges often require local solutions, and the preferred approach depends on local institutions governing resource use, soil characteristics, groundwater aquifers. So most of the analyses of these issues are undertaken at the local level, and it's very sensible. However, when it comes to meeting these UN Sustainable Development Goals, local planning can't take place in a vacuum. Future stresses will depend on national and global drivers of change, including population growth, income, domestic and trade policies, other broad-scale factors. So to capture these cross-scale effects, global to local to global linkages must be considered. And the third limitation has to do with the proprietary or complex nature of most of the analysis frameworks currently used. Tackling this kind of a wicked challenge, this problem that involves many complexities, typically means that the work is done in large national and international institutions. However, until recently, most of the modeling frameworks that have been used in these contexts have been proprietary in nature, so they haven't been freely shared. And when they are open to others for use, the public response has generally been limited. This is due to the complexity of the underlying modeling frameworks, and they're often getting more complex over time as the frameworks are enlarged to deal with new challenges. If we're to build a community of practice around analysis of the SDGs, the models must be developed from the very outset with the idea that they'll be used by a variety of individuals with differing backgrounds and skill levels. So GLASS aims to transform the way in which we address the analysis of SDGs by addressing these three limitations. This is nicely illustrated by the recent publication of Liu et al., published in Environmental Research Letters in 2017 and currently featured on the Geo Hub. This study examines the challenge of attaining sustainable levels of irrigation withdrawals around the world by 2050, and it highlights the trade-offs between limiting irrigation on the one hand and ensuring food security, limited cropland conversion, and minimizing terrestrial carbon emissions on the other. So they're trade-offs. And towards this end, the authors use the Simple G modeling framework. Simple stands for a simplified international model of prices, land use, and the environment. And the global gridded version used in this study, Simple G, disaggregates the world into 36,000 grid cells representing the world's croplands. So this model can be run and results can be visualized today on the Geo Hub. I invite you to do so. It can also be freely downloaded, and you can find more details and instruction on the simple model in the course section of the Geo Hub website. There are instructional materials as well as a textbook. So this is but one of many open source tools, data sets, and modeling frameworks which are being made available on the Geo Hub. And in closing, I'd like to invite you to contribute your own tools to the Geo Hub. Once published on the Hub, they can receive a DOI, a digital object identifier, which will facilitate citation of your work by others who will then build on these tools to contribute in their own way to charting a sustainable future for our planet.